Hi, I'm Mateo Ball, and we'll be looking at the 8.2 Ka event that took place 8,200 years ago, affecting climate change. By looking at the relationship between North Atlantic temperature and climate, as well as past climate changes, we will try and discover a cause for the 8.2 Ka event. An increase in CO2 has caused climate change today. CO2 does this by trapping heat in the atmosphere, caused by its ability to absorb infrared energy from the Earth before it exits the atmosphere into space. Today, our carbon dioxide emissions are higher than ever before, drastically impacting the ice sheets on Earth. The Greenland ice sheet has lost 150 to 250 cubic kilometers of ice just between 2002 and 2006. By looking at what's happening to the Greenland ice sheet as CO2 increases, we're able to look back at the 8.2 Ka event and look at CO2 levels and how they were rising prior to the event taking place, suggesting that CO2 played a role in the demise of the Laurentide ice sheet. The Laurentide ice sheet was the major ice sheet during the Ice Age. Lakes Agassiz and Obiwe formed from the Laurentide ice sheet's meltwater. The water from these lakes would flow through the Mississippi River into the Gulf of Mexico. As the ice sheet began deteriorating from the CO2 increase and glacial calving, which is the ice chunks breaking off from a glacier, the lakes grew substantially between 9,000 and 8,200 years ago. As the Laurentide ice sheet shrank, it eventually gave way, allowing for the lakes to flow out into the Hudson Bay. The fresh water poured out at a rapid pace into the ocean, raising the sea level a full meter. This changed the density of the ocean water. As you can see in the figure, the meltwater went through the Hudson Bay out into the ocean. Thermohaline circulation is also known as the ocean conveyor belt. The ocean conveyor belt was affected by the change in water density. The conveyor belt is what brings cold water down toward the south and the warm water up towards the north. The density of the water allows for the water to sink into the ocean and travel south. Due to the drop in the water density from the fresh water, it was unable to sink down to return. The conveyor belt was halted, keeping cold water in the north and the warm water near the equator. Since the water was cooling, it caused the surface temperature to drop in the North Atlantic and Greenland, as well as an increase in temperature of the middle of the planet, with the warm water staying there. The 8.2 Ka event was not the first of its kind. The Younger Dryas took place 13,000 years ago and was the longest cold spell, lasting roughly 2,500 years. The cause of the event was almost identical to that of the 8.2 Ka event. The meltwater from the Laurentide ice sheet opened up a channel for Lake Agassiz to funnel out eastward into the ocean. The drainage caused the lake elevation to drop by 40 meters. The fresh water affected the thermohaline circulation just as it did in the 8.2 Ka event. Some people speculate the reason the Younger Dryas caused more severe climate change was due to the fact that the water flowed directly into the ocean, as opposed to flowing through the Hudson Bay and then into the ocean. The Laurentide ice sheet is the main driver behind the climate that took place. As the temperatures rose, massive pockets of meltwater formed until one big lake was contained by the Laurentide ice sheet. Once the CO2 was raised even more, the Laurentide ice sheet collapsed over the Hudson Bay, allowing for the meltwater to enter the ocean. The fresh water caused the ocean water to lose density by diluting the salt. When the water loses density, it does not allow thermohaline circulation to take place due to the fact that only dense water sinks. This slows down the process, keeping the water exactly where it is at the time. Leaving the cold water in the north and the warm water in the equator, the water affects air temperature, creating an environment that gets colder in the north while the equator gets warmer. These were the events that led to the 8.2 Ka event. Thank you so much for listening.